My name is Aaron Smith, and this is a demonstration of the Spark Natural Language Processing API. The Spark Natural Language Processing API is a relatively new API. It's an extension of the Spark machine learning and pipeline API. It includes a large number of functions and annotators that are common for natural language processing tasks. Unfortunately, because it's so new, it really lacks a lot of the documentation and community support that many other APIs have. To use this API as a demonstration of sentiment analysis, we didn't do that in class, but again, it's a really popular use of natural language processing. I just tried to pick three texts that I thought were easily accessible, were large, and would be interesting to analyze. So I picked the three most popular religious books of all time, the Bible, the Quran, and the Vedas. It's the four Vedas. And so what we'll do as part of this is we will try to determine the aggregate sentiment for each. So we'll add up the positive sentences, subtract the negative sentences, and we'll get a sentiment score for each one of those. And then just a quick review of the installation and then the specifics around my environment. So for the NLP API, the real requirement is a working version of Apache Spark 2.11 or greater. And before I go over to the demonstration, I did want to just talk through the data sets that are required in order to perform this analysis. So I got the English version of the three religious books, so easy internet search can get you any of those three. Obviously, the version of English translation will have some bearing. There are multiple translations for many of these books, so again, I picked the one that was most accessible and appeared to have the cleanest text format. The default lemma dictionary. So the package itself actually has a lemma dictionary, and it looked fairly robust. You can you essentially use one of the functions to point to a text file, and that text file is the lemma dictionary, which again I'll review in more detail in the demonstration. But I thought as a way of demonstrating the API, it would be good to use the dictionary that the API provides. That is a similar case with the sentiment dictionary. The only issue I have with this is it is not very robust. It really needs more development, but it is part of the API, and so since the intent of the demonstration is to show what it is provided with the API, I'm going to use the default one. However, I think in a real-world application you would probably want to find a different one or create your own. Again, this is we'll use a function and point it to a text file, which is this dictionary. So without further ado, I will hop over to my environment here, and I'll log in. And I have taken a couple of preparatory steps just in the interest of time, so I do want to review those with you. As mentioned, I just opened my terminal and I launched PySpark with the package. You can see that it initializes it with the package. And then because I'm going to demonstrate this in the terminal and there's a lot of copying and pasting, and I've only had 15 years of practicing my copy and paste for this demonstration, I thought it would be nice if I went ahead and did some of the less valuable commands. So I've imported the packages that I need to import, and then I'm not operating on a very powerful computer, and even though these text files are not that large, they are large enough to take some time to load. So I have also loaded each one of the text files, and then as part of the pipeline we're going to build later, I refer to the text files as text, and it imports with the column name value. So I've also renamed each of these. And just to give you a sample of what these text files look like, we won't spend too much time on this. So this is the Bible text, and I'll give it a second to load up. And we'll scroll down. So as you can see, it's the Bible. I believe we actually worked with this exact version of this text in the class from the Gutenberg project. All right, so this is the script that I'll be copying and pasting from to go through the demonstration. The next thing, so I have, again, I've already imported the packages and load the data in the interest of time for our demonstration. So the next thing I'll do is build the pipeline. And so the pipeline is a sequence of the natural language processing functions delivered through the API. So I will just start going through these. We did already talk a little bit about what the document assembler is. It more or less initializes the process by creating the first annotation. The other interesting thing you can see as I'm going through these is the output of one is the input of the other. Obviously that makes sense, and then we'll sequence them at the end. But so we'll take the document and pass it into the sentence detector. And of course we mentioned this in class, but Spark doesn't actually do anything with this until you need it to produce an output. I think that was called lazy processing. So we've taken the document, we've passed it to the sentence detector. We'll take the sentence detector, results from the sentence detector, and pass it to the tokenizer. There is more parameters you can set. The default is just to break it into words, but it uses the normal regular expression functionality. And then the normalizer, again, so that's for cleaning the words. So in this case, the default is just alpha characters. So in many of the religious texts we'll be processing, there are numbers and hyphens and colons and things like that throughout the text. So we'll want to take each word and normalize it so that it is an actual word. And then if there are any spelling issues, we'll want to correct those. Again, these books are pretty popular. I would be surprised if there were spelling mistakes in them. But again, if you ever wanted to use this pipeline for a different text later, having the spell check in there might be good. I would imagine if you were using text from, say, Twitter or Facebook, a spell checker would become really important. So now that we've broken our sentences into words, we've cleaned them, we've made sure they're spelled correctly, we'll then pass it through the lemma dictionary. And again, this references that lemma corpus text. You could easily download a different, assuming if it was in the same format, you could download a different lemma dictionary and simply put the path to that file here. So we'll paste that over. All right. And then our last step here is the sentiment detector. So again, that references a dictionary path, and that was our default sentiment file that I previewed for you a couple minutes ago. And then our finisher, which turns the results of all of this into like human readable strings. And then this has a lot of parameters around how you want to clean up the output of this, and if you're interested in those, you can certainly reference the documentation on it. Alright, so now that I've created all of these more or less functions or pipeline components, I have to actually set the sequence of the pipeline. And so again, because the input of one becomes, or the output of one becomes the input of another, we've got to get the sequence right for all of these. So we create this pipeline. Put that here. And again, it's not actually processing anything because we haven't told it we need to see results yet. And so the next one will actually run the pipeline for the 3 different texts. And so you can see it's pipeline.fit and then the text. That's how I imported the text files at the beginning. So we'll move that over. And these will take a little while. But really what we're doing is we're going to take the result from the pipeline and we're going to filter it for a positive sentiment or a negative sentiment, and then we're going to count those. So we'll go through each one of these. Okay, and then just to prove that it did something, I'll just print out a positive result. So we have a little over 100,000 with a positive sentiment. So I'll pause and go through the rest of these. Alright, thanks to the magic of our recording device, I've now actually gone through and captured the negative and positive results. So since you have traveled through time, just to demonstrate that I didn't do any funny business, this is the last thing we left off on, was printing the Bible results. I then went and did the negative sentiment for the Bible. I messed up a copy and paste for the Quran, but a positive and a negative for the Quran, a positive and a negative for the Vedas. And again, in the interest of time, I also just captured the total count for the Bible, the Quran, and the Vedas, and then created a percentage, so the number positive divided by the total Bible. And so from here, so again, we've gotten results. These are astronomically high positive results. You would not anticipate that it was any of these texts would be that positive. It's hard to imagine any text at all being that positive. And this is due to an issue that's actually logged in the GitHub, where the sentiment defaults to positive if it's not otherwise assigned in the dictionary, and their dictionary is fairly sparse, and so we end up with a lot of unassigned things that end up being very positive. So that's the cause. Worked on, I'm sure if you got a more robust sentiment dictionary, this would take care of itself. So, alright, so now that we have those results, we'll go ahead and create our visualization. I think I'll probably just create one of these and then show you the results of the others. For that, we're going to import the very popular matplotlib, creating the labels, and then so that those are text for what each slice of the pie represents, and then using the values in this sizes you expected, because this was 99.8 or something positive based on the sentiment dictionary we were using. This is what the pie chart looks like. Just to go back over here, this is what it looks like for all of them. So the I enjoyed using this API. This was an interesting experiment. I think, again, the big drawbacks are that it is still actively in development. It's relatively new. There's very little community support for it. I would be interested in what these results would look like with a more robust sentiment dictionary, but again, for the purposes of demonstration, I wanted to use the resources that were provided as part of the API. So I know I learned a lot going through this exercise. Hopefully everybody else has learned something with this demonstration, and thank you for your time.